Hey, honey,
Yeah.
you check the like not eh, you're not here on Wednesday, am I right?
No, I will be here Wednesday, or I
It's
should be. Yeah,
not Wednesday, not Wednesday. You're not here, am I right?
next Wednesday I'm not
Not
here.
last last like last Wednesday.
Oh, last
Yeah,
Wednesday.
last Wednesday. Yeah.
Oh no, I'm pretty sure I was, I thought.
Oh, you were? Okay, I need to check the record. Anyway, because last Wednesday is very important. Yeah, yeah, yeah. You. Oh, I remember. You are here. You were here. Yeah. Okay. Yeah, I remember now. Okay. Yeah. I think. Yeah. Let's start today's class. Yeah. Okay. Let's start this class. Yeah, today we will continue talk about the like a conclusion thing. Yeah, actually, we last class we began to focus on LIT system. Am I right? And for the LIT system, like there are like a CT like a system, like a DT system. Like today we will like continue to talk about that. Like we know like the convolution we can use convolution to represent an output of a system. Yeah, we have already proved that. And today we will like focus on the discrete time convolution sum. Yeah, we will try to focus on the discrete time signals. Yeah, and
Oh, I have a quick question. My bad. I meant to ask this before you started. So I know in last like you posted something on Blackboard that was talking about how the homework is gonna be done differently now.
oh
Can you
yeah,
like
yeah.
briefly explain that? Yeah.
Yeah, because like I found when there is only one due date for the all homework, I found most of you just start the homework very late.
Yeah.
Yeah, there is no time. Yeah, because like our exam, like I said, it's just from the homework and the maybe examples we talk about in the class. So.
Uh-huh.
Yeah, yeah, yeah. You don't have enough time on that. Yeah.
Okay, that makes sense.
Yeah, yeah,
So
yeah.
all
So,
so you put all the dates on Blackboard for the new due dates?
yeah, yeah, yeah,
Okay.
yeah. Usually, it's just like 1 week after 1 week later after I publish the homework. For example, not Wednesday's homework will due on this Wednesday. Not Friday's homework will due on this Friday, like that.
Oh, okay, okay,
Yeah,
I
yeah,
see.
yeah, yeah. Yeah, that makes sense to you?
Yeah, that makes sense. I just had to clarify to make sure that's what was going on.
Okay, okay, no problem. Yeah, yeah, question about the homework. Do you have any question about the due date? Because I changed the due date, like for the chapter 2. Yeah, 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 it's just like a 1 week later after I publish it. Wednesday, this Wednesday will do on next Wednesday, this Friday will do on next Friday. Yeah, I think this will be better because you can see the exam is just from the homework. Yeah, if you yeah. Okay, yeah. Let's continue today's class. And today, we will focus on the discrete time convolution sum. And this is today's goal. And firstly, we will review the linear convolution theory for DT LIT systems. And then we will try to apply the shifting property for convolution with impulse delta n. And then finally, we will compute the DT convolution sum using the geometric series. Yeah, I know the geometric series is now you don't like it, honey, but yeah, yeah,
Oh yeah.
we'll talk about later. Okay, and okay, let's try to sum of the DT LIT systems. Okay, and this is shifting. This is now shifting. This is sampling property for the signals. What's this equal. What's the result for this equation? What's delta n? What's the name for delta n?
What are you at? You're asking the answer?
Yeah. Your answer. What's the name for the delta n? What's the function name? Huh? Samples? Impulse? Oh yeah, impulse. Yeah, impulse function. What's the property for the impulse function? When n equals 0. This one for 1.
X of 0.
Otherwise it will still 0, am I right? Yeah, only when n equals 0 it will be 1. Otherwise it will be 0, am I right? So
Yeah.
xn multiple delta n, what will it will?
X.
This is 0.
Huh? Minus now that haven't yet haven't arrived yet. You know, like the delta n is when n equals 0, it will be 1. Am I right? Otherwise it will be 0. Am I right? So yeah, the xn multiple this function when n equal doesn't equal 0, and it will be 0. Am I right? Only when this is sampling property. Yeah. You can see when n equals 0, it has a value. Otherwise, it doesn't have the value. We talk about that. Am I right? Yeah.
Yeah.
If you have any question, just directly ask me. Am I right?
All right.
Okay. And then from the sampling property, we have this one. What's the value for this one? Yeah, this is what you just talked about. Yeah. What's the value for this one? Yeah, shifting. Yeah, you're right, shifting. So let's talk about. Actually, it is shifting, but sometimes if you don't, you try to understand now using shifting, maybe using just as a property for the delta, like a function. What is the delta? N minus n now. What equal what? When n equal n now, what's the value? When n equal n now, what's the value for here? Yeah, 0. What is delta 0? Yeah, 1. If n don't equal, what's the value? Yeah, 0. Which means when n equal n now, the function will have the value 1. Am I right? Which means it will like sample the xn n now. That makes sense to you? Yeah. And then this is sampling properties. From the sampling properties, we have this one. Xn equal this from k, from negative infinity to infinity, now add them together. Yeah, from the sampling property, we have this one. We have already proved it. Yeah, do you remember? Yeah, in last class. Yeah, if you forgot it, you can review that one. And then this we name it dt safety property. From dt safety property and other thing. Let me ask you a question again. What's the name for this delta impulse function, Amra? What's the name for Hn? Actually, there is a name for Hn. Huh? Don't remember? Do you know, honey?
No, I don't remember.
Okay, it's called impulse response, which means this is based on the one system's response, like that. We call it an impulse response. So what's the meaning for Hn? Like what is Hn exactly? Do you remember? Yeah. It's output. Yeah, exactly. It's output, which means Hn is just like there is one system, and the input is delta n, the Hn is the output for that system. Yeah, which means different system, you have different output. Yeah, that makes sense to you? Yeah, okay. And then, yeah, this name is impulse response. And from this, and this DT shifting property and the impulse response we have. And also based on the system is the LIT system, we have this equation. Yeah, we have already proved it. Why this equation works? Do you remember? Like we have the yn equals this one. If you forgot, you can review the last class. Okay, and then from this equation, actually we have a symbol to represent the convolution. Yeah, this is the convolution process. We call this whole thing convolution. This is a convolution equation. But we have a symbol to represent convolution. What is that symbol? Do you remember? Do you remember?
Which symbol?
A symbol, like a symbol, like a you mean like a multiple, we use this one. And multiple, we use this one. Not multiple, divide. And multiple, sorry, plus we use this one. And multiple, we use this one. Like this is divide and this is minus, right? So what symbol we use for the convolution? We know that the convolution is an operation, right? Huh? Multiplication is multiply. Yeah, multiplication is just a multiply. Am I right? Yeah. So we have a symbol to represent the convolution. What's that? Oh, maybe you call it multiplication. You mean this one?
Yeah, that's multiple.
This is multiplication? I think this is multiplication. What's the name for this one?
It's the same thing.
Oh, it's not the same thing. It's obviously not the same thing, right? So I think this is a multiplication.
I write 3x3 9.
Yeah, x. You mean this one?
Yeah.
Yeah, this is multiplication. I know. Multiply. Yeah, but this one is convolution. Yeah. Yeah. It's different. Yeah. Like
Yeah. Well, in my math class would use that star.
yeah, I know. Like this one sometimes, especially when you program. Yeah. You just use this as a multiplication. Yeah, but just remember in our signals and systems class, and this is multiplication, and this is convolution. Yeah, using star like that. Yeah. I don't know how star thing. Yeah, and then okay. So this if we look equation also can be represented like this one. All right. Yeah, we talk about this one, and this one equals this one because the shifting property, and pay attention, the shifting property and the shifting property, it's different. Yeah, this is we call it a convolution sum. Yeah, this is we call it convolution sum. And from here to here, we have already proved it. Yeah, and then we know. This is communication property, and also for the shifting property. Do you remember what is shifting property? It has some shift. Yeah, you can see if we have this one equals this one. Yeah, this is shifting property for the convolution. Yeah, if you have a convolution like this, and then you can get this one. Yeah, we call this shifting property. Yeah, any questions so far? Yeah, this is what we talk about in last class. Okay, and then let's talk about convolution. There are some properties, convolution properties. Sorry, the first one, do you remember? The first one is a shifting property, am I right? We talk about, and the second one is what? Do you remember? Yeah, like a community property, which means and the second one is what? Yeah, distributive. And the third one, the next one is yeah, associative property. And for the commutative property, we have this one, which means you can change the order for those two atoms. And the distributive property, which means there is a like a pattern, and you can put it into this and multiple convolution, those two, and class, and then convolution with this one. Yeah, just remember here, the star, this symbol represents convolution. Yeah, it's not multiplication. And yeah, and also and the associative property, which means if you, yeah, those three will be safe. If you convolution three atoms, you can convolution this one and this one first, and then this one. Also, you can convolution this one, and then each one. And also, you can convolution H1 and H2 firstly, and then convolution with X. Yeah, so it's the same time. It's the same thing. Actually, this convolution can help. This convolution properties can help us to simplify our computation. You can see if you want to. Let me ask you a question. Why we want to why we want to analyze this thing? What's the purpose for this process? Yeah, you know, like in the real world, you have a system, phone, am I right? Robot system. You have a class robot class. No, no. But maybe you will have later. You have a system, phone, am I right? Or robot, a small robot, big robot, or a monitor, any system. You may have a input signal. For example, this is monitor. I give it, I click HDMI 1 or 2. This is the input signal, am I right? For example, I can represent this signal in a mathematical form. For example, I have XN, am I right? And then I have a system, like a monitor system. This system maybe like one. If I press like HDMI like 0, if I don't press HDMI, this is my signal, am I right? Input signal. And my system monitor, you know it. I give I show you a monitor. And do you know the system? You don't know. Am I right? Sometimes sometimes I give you a phone. You don't know that phone's system, the mathematical form. And so, for example, the robot. Sometimes you don't know. Am I right? But delta n. Do you know that? Do you familiar with delta n? Yeah, delta n is just like an impulse function. Am I right? Which means if you have a system and then you have a delta n, and then this delta n is 1, 0, 1 n into 0, and 1 n put now equal 0. And then you just give this system theta n as an input, and then you can get output. Sometimes if you this monitor is just example, some robot, you give delta n and you have some output, you can measure it, am I right? And then you can see, you don't know the system, the whole system, but you can use this equation to represent your output. And then you can get your system, your whole system representation, mathematical representation. That makes sense to you? Yeah, that's the reason why we want to learn this whole thing. Okay, let's continue to talk about the properties. And this whole thing these properties can help us to simplify this equation. Am I right? Yeah. And we have this we have an example. I think this example we talk about this last time. Okay, yeah, this one. If we have xn, we know xn, am I right? Input signal, we know hn. Hn, what is it? Hn's name? Impulse response. And then we can get yn, am I right? Yeah, because we have the equation, this one. And for this one, yeah, we can like use this is a communicative properties. We can get this equation, and then we can have this one, and then we use what property? I think we talked about this example last time. Distributive, yeah. This one, am I right? And then what property we can use? Shifting, am I right? Yeah, this one, shifting property. Here, am I right? And then we can, yeah, shifting properties. We have this one. That makes sense to you? Yeah, and what is xn plus 1? Yeah, we have xn. So what is xn plus 1? It's easier for us to get, am I right? What do you think? Do you think it is easy for us to get? Like, yeah, x equals plus 2 minus 1 and then x plus 1. You just replace every n with n plus 1, am I right? And then you can get what is xn plus 1. And xn minus 1, you can replace n with n minus 1, am I right? So you can get xn minus 1. That makes sense to you? Yeah, so we can get this one. That makes sense. And then we just combine the same item, for example, this one and this one. That makes sense to you? Yeah, and then finally we get this one. Any questions so far? Any question? No question? Okay, then what this example tell us? This example tell us if you know the input signal, and if you know the system's impulse response, you can using this equation to represent the system. Am I right? The system is I give you an input and then I have output. Am I right? You can represent this system. That makes sense to you? Okay, let's continue. Let's talk about this example. Yeah, this is like what's the name for this one? Impulse. What's the name for HT? What's the name for HT? Yeah, impulse response. Yeah, I just want to like repeat it again and again, let you to remember that. Okay, this is our signal, input signal. Yeah, our input signal is just like this. Am I right? So you can easily get our output with this equation. Am I right? And then we know like this is HT. Am I right? Yeah, we just put it here, and this is XT. And what property we use firstly? Distributive, am I right? And then shifting property. Yeah, we can have this one. Actually similar with the previous one. That makes sense to you? Yeah, so then you can have the like equation to represent this system. That makes sense to you? Okay, let's try to, yeah, this is the YT. Okay, let me ask you a question. Why YT? Why YT's figure is just like this? Do you know why? Yeah, because you can see YT equals this one, right? So what is XT minus T now? Yeah, it's just like try to right shift, right? This one. And what is XT plus T now? It's just try to left shift. It's this one. And then add them together. It's just represent the whole YT. That makes sense to you? Okay. Yeah. Okay. Let's try to. Yeah, this is a. Yeah, T now. There is a. Okay. Okay, let's try to review example 3. Okay, this is the impulse response of a LIT system, am I right? And then HT can like draw like this. And this is our input function, signal or function. Yeah, and what is YT? What is YT? Yeah. Just remember this equation. Always remember this equation. Yeah, we have already improved that. If you know the xt, here the x, I talk about the n here, but the t is the same thing. Yeah, it's the same thing. Yeah, I think I forgot that to point that. I just yeah, and then here. So what is YT? Convolution, am I right? Yeah, just a convolution. This is the system output. And then, like, what? Okay, then it will equal this one. Oh, why is this one equal this one? What? Using which property? Which property? Huh? Yeah, actually, the convolution properties have four different properties. The first is shifting, and then communicative, and then distributive, and then associative. Yeah, so which property? Huh? Yeah, distributive. Yeah, you can see here. The xt equal that one, am I right? And it's just a distributive and multiple inside the petalist. Yeah. Yeah, this is a YT. Yeah, if you draw it and you just try to and then what properties you can use from this step? What properties you can use? Oh, I think I forgot one thing. Usually, we want to represent the system. What's a system? Recall that. Yeah. The relationship between the input and output, am I right? Usually, we just want the equation for the system. It's just the pure a relationship between input and output. Here, we don't want the impulse response. Yeah, you can see the example 2. Yeah, finally, we just have the relationship between the input and output. And for the example 1, you can see, yeah, finally, we just have the, yeah, just from here, sorry, from here, you can see it's just the relationship between the input and output. Am I right? We don't like, actually, we don't like the impulse response. Yeah, you need to try to figure out how to remove that impulse response. Just find the relationship between the input and output. Yeah, that makes sense to you? Yeah, this is the system. That makes sense to you? So for this one, we have this one. So, but we just want to represent it. We don't like HT, am I right? Because this is response impulse. So what should we do? What shift? Actually, we can use the convolution properties to get that. What properties we can use? Yeah, for this one, do you have idea? If this one you don't have idea, for this one, do you have idea? Shifting, am I right? Because you can see, just remember these properties are very important. Yeah, here Hn is just like a Xn here, am I right? So you can use some shifting properties like this, am I right? And for now, you have this one. You have HT, am I right? So your YT and your YT should equal this one, am I right? Am I right? Yeah, you might have a question. We want to find the relationship between the input and the output, am I right? But here, there is no xt, am I right? But there is no xt, but this is some specific signals, am I right? It is fixed signals. It will not change, Am I right? Yeah, because you can see ut, what is ut? It's just step function. Am I right? What is e? It's potential signal. Am I right? It's just similar like this. Am I right? So it's just like the fixed. You can easily to draw the yt like this. Am I right? That makes sense to you? Okay, any questions so far? Okay, let's continue. Oh yeah, you can easily draw this one like this. Okay, let's try to see the other one. This is the Hn and this is the Xn. What is the system? What is output? What is output? Huh? Convolution, am I right? Yeah, convolution. Just remember, just use convolution firstly. Convolution sum, am I right? Yeah. And then since like the k x is just from -1 to 1, yeah, for the xk, you can see only like k equal -1 to 1, it has value, right? Otherwise, it does not have value. So we just put this equation, simple this equation to this equation. That makes sense to you? Okay, and then we have this one. When k equals -1, and then here hn plus 1, and then this one. That makes sense to you? Any questions so far? No, am I right? Okay, and then we have this one because what is x -1? 1, right? So we have this one. What is the x0? 2. What is x1? We have like a 1, all right? And then what is this? What is hn plus 1? We have hn, right? What is hn plus 1? Are you sure? But hn is like this, am I right? Hn is this one. What is hn plus 1? You mean hn plus 1 equal 2? Yeah, actually you can say hn, this one. If you want to get this one, you need to shift it. Yeah, shift it to the right. So it will so shift it to the left. So it will equal to this one, am I right? Yeah. And how about the hn? Hn just you know that. How about hn minus 1? Just shift to right. And then here, this is 2hn, sorry. And then shift it to the right, hn minus, and then add them together. Yeah, this is 1. That makes sense to you? Yeah. So for some like examples, maybe you can use some like you draw it and it will help you to simple your calculation thing. Yeah. Okay. And yeah. Or you can also use this equation. Yeah, we know like the x if hk can in the first order and the x n minus k it can change the order. Yeah. So it's a similar thing. Okay. Then let's check the other one. If we have a LIT system whose output is 1n equals this one, find the following convolution. What is this one? Okay. Yeah, we know like wait. Oh, sorry, I think this example I didn't give you. Sorry. I think I didn't give you the xn and hn here. Am I right? Let me see if I. Oh, sorry. This is not an example 5. This is just a continuing example like a 4. Sorry, this is, yeah. If we have a LIT system, find this one. Yeah, since our Oh, yeah, sorry. I think it's wrong. Yeah, we have this LH system, Yn equal Xn convolution with Hn. Then we want to find this convolutions. We want to find the following convolution, the relationship between the following convolution with the output Yn. Yeah, this is our question. And then you can see when you see this one, what properties you can think. Yeah, it's a shifting property. You can see, you can use this one to represent this one. That makes sense to you? Yeah, this is a shifting property. That makes sense to you? Yeah, and then what properties we can use? This is shifting properties. And then some like a communicative. Yeah, this is communicative properties we can use. Which we'll try to put because we have this one, am I right? We have Yn equal Xn convolution with Hn. We want to represent this with find the relationship between this one and the Yn. So we have this one, commutative property, and then we have this one, because this one and this one, these two, we also can use the shifting property. Am I right? Yeah, we have this one, and then we have this one. That makes sense to you? Yeah, this is just like this one equals this one. What's the property we use here? Also shifting. Am I right? You can see. Yeah, also shifting, because you can see if you see this, if you see some like equation have this one, but the result there is no this atom like the impose like function, which means you use the shifting property. That makes sense to you? Okay, let's continue to talk about sorry. And then, which means this one equal. Oh, this is a similar thing. If you just want to find the relation between this one and the Yn, the similar process. Am I right? Yeah. So you will have this you will have this result. That makes sense to you? Yeah. Using some shifting property and then commutative property, shifting. Yeah. And you will have this one. Yeah, do you want to expand it for you? I think this one will be easier. Am I right? Huh? Yeah, you are good. Okay. Honey, are you good?
Yeah, I'm good.
Okay, that's great. And then let's try to talk about the analytical convolution sum. Actually, this part is focused on the discrete time convolution. Like we talk about, we will focus on the discrete time convolution sum. And the convolution sum can be computed analytically in two cases. Yeah, case one, if Xn and Hn are given as short impulse sequences. Yeah, for example, this and you can use shifting property and distributive property to have this one to get your output thing. Yeah, if you which means if your Xn and Hn are given as a short impulse sequences, and the shifting property and the distributive properties can be used to help you to get the output. Yeah, and the case two, when the Xn and Hn are defined with a closed form, the key is to convert the convolution sum into the geometric series sum as this form. Yeah, or this form. Yeah, the first form or the second form. And actually, we have already talked about the case one. Yeah, you can see the example like 5, 4, and 1 is also the case one. Am I right? All are all about case one. And the case two we haven't talked about. And I will give you some example. Do you know what is a closed form? Infinity? Now infinite. Yeah. That's true. Yeah. And if you know, sometimes like the xn and the hn are now given using this short impulse sequences. Yeah, so you will need to use this equation to resolve this case too. And let me give you one example. Yeah, for example, this one. This is your like input signal, and this is your impulse response. And then what is your yn? What is your yn? Just remember that yn is just it's just what? Output? Yeah, the output. What is output? Just remember this equation. Let me repeat it again. Yeah, the convolution. Yeah, just remember this one. Yeah, if you have xn, yn, just try to use the convolution. I mean, this is a convolution. And then, but you can see this one and the xn and hn is not like the simple short impulse sequences. I'm right. But it's form like it's just like a closed form. Yeah, so you just using this equation. Yeah, this equation is similar with it's just the convolution. Yeah, I'm right. So this is xn. I'm right. And this is hn minus k. I'm right. And then you can see from this one you can have this one y. Yeah, this is the point. Why this equation can equal this equation? Yeah, let me ask you, what is u function? What's the name for u function? Step function, right? What's the property for step function? Like un, let's just talk about un. What is un equal? When it is equal 1, and what? When it is equal 0. Am I right? So let's check the first item. This one. Okay, so sorry. Let's check the first item. This item. UK minus 2. What does that mean? Equal what?
1 s greater than
Am I right? If it is greater equal 0, am I right? This part, which means k greater equal 2, it will be 1. Otherwise, it will be 0. Am I right? So that's the reason why this equation here there is no this atom, because I just let k greater than 2. Am I right? So which means this atom will be 1. I just remove it. But why I remove when k smaller than 2? Then it will be 0. Am I right? So this atom, every atom, it will be 0. You don't need to add it to this equation. Am I right? So we can get this one. And then let's continue to talk about it. How about this part? What's the situation for this part? Actually, if we want this part, un minus k plus 2, this part equal 1, which means n minus 2 plus 2 will greater equal 0, right? Which means your n should greater equal k minus 2. Am I right?
Yeah.
Yeah, but you can see this one, am I right? Which means which means let's talk about k. Yeah, here, because our like this here we talk about k, am I right? So we need to focus on k. So k smaller than n plus 2, am I right? But here, do you know n? What is n? You don't know, am I right? Yeah, you don't know. So which means you need to talk about that. Which means here, this is your like if k smaller equal than n plus 2, it will be 1, am I right? Otherwise it will be 0. So we have this range, am I right? Yeah. So, but you don't know n, am I right? N plus 2 may be greater than 2, am I right? Maybe n will greater than 0, but it will equal this one. Yeah, but it will matter smaller than yes, this one maybe have, if this part is smaller than 2, it will have the other situation. Yeah, we will talk about that in next class. Yeah, is that okay?
Yeah.
Okay, any question? Okay, yeah. Honey, any questions?
Nope, I'm good.
Okay. See you on Wednesday.
All right, see you later.
Okay, bye.
So we don't have,